Right, here we go, kids. We are going to be talking about topic 10.2, comparing rates. You will need to open your book to pages 258 and 259. So pause the video and do that right now. Okay, here we go. We're going to talk about comparing rates. And before we do that, we're going to do a quick review of information from different topics. A rate is a special type of ratio. Okay, so it's a special type of ratio that compares quantities with unlike units of measure. And that's the key. You want unlike units of measure in order to be working with rates. Okay, and that's what makes it a special type of ratio. Some examples would be miles per gallon, different units, distance to capacity. Okay, another type of rate would be miles per hour. Again, a distance to a time. RPMs, revolutions per minute. IPH, inches per hour. Again, you have a measurement of length and a time. So you have units of measure and units of time in that one. A couple examples, okay, and how you would use them. A unit rate is another special type of ratio, and a unit rate is a comparison to one unit, okay? Unit rates are found through division. An example of that would be this, miles per gallon. Okay, so in this case, you would have a ratio of 66 miles to 3 gallons. If we wanted to come up with a unit rate, we could do it two ways. We could create equivalent ratios and do the division through this method, and we would get 22 to 1, or we could remember that we are actually dealing with a division expression and put our 66 in there as the dividend and 3 as our divisor, and divide in the traditional sense or traditional algorithm and come up with the same exact numbers, okay? So then what we would have is we would have our rate would then be broken down to a single unit, and it would be a 22 to 1. So it would be 22 miles to 1 gallon, okay? And so that's what we mean when we talk about a unit rate. Another example would be this one, revolutions per minute. Again, if we're talking about a unit rate, we would set it up as a fraction, 60 to 12, or 60 revolutions to 12 minutes. And again, we could divide with the traditional algorithm and deal with the expression that way, and we would get 5, and we would find out that we would be able to divide 12 by 12 to get our 1 unit, which would be 1 minute, and divide 60 by 12, and we would get 5, which would be our revolutions. So the unit rate for this ratio would be 5 to 1, or written as 5 to 1, okay? Why don't you, with a piece of paper, see if you can find the unit rates for these situations. Steve ran for 38 minutes. He went 4 miles. How fast is he running each mile? Pause the video and see if you can come up with the unit rate in this problem. All right, let's see how you did. Well, again, we are comparing minutes to miles, time to distance, and our ratio is 38 to 4. If we write it as a fraction, we would then write it as 38 over 4. Okay, 38 to 4. And then again, if we want to find out what the unit rate is, we would want to know miles and time, and we'd want to know how much time it takes to run 1 mile. So in this case, we would have our unit of 1, and then we would take 38 and of course divide it by 4. 4 will go into 38 a total of 9 times. That's 36. Subtract and you end up with 2. Now what we're going to do is put a decimal point in our problem and annex a 0. Bring down our 2. 4 into 20 will go 5 times. 5 times 4 terminates the problem. So we would have 9.5. So the unit rate would be, he runs in 9.5 minutes, he will run 1 mile. So he's running a mile in about 9.5 minutes. Okay, and that would be that unit rate. Let's try another example for finding unit rates. See if you can figure out this runner's, how far he travels, how long it takes him to run a mile. Okay, let's see how you did. Bill ran for 74 minutes. Okay, so his ratio is 74 minutes to 8. So it is a 74 to 8. And so in this case, it would be 74 over 8. And so we would simply do the division. Again, let's take it and use the traditional algorithm of 74 divided by 8. 8 will go into 74 9 times. 72. Subtract, you have 2 left over. Put a decimal point in place. Annex a 0. 8 into 20 will go a total of 2 times. 2 times 8 is 16. Subtract and you have 4. We're going to annex another 0, bring it down. 8 into 40 will go 5 times. 5 times 8 is 40. And so we have 0. So our ratio, our unit rate for this one, if we were to divide by 8, and we would end up with 9 and 25 hundredths minutes compared to 1 mile. Okay, so now what you could do is you could actually say who is running faster than who, okay, by comparing unit rates, okay? So this is how you would find a unit rate. And once you're able to find unit rates, you can then compare them and ask yourself who is running faster and who is running slower, okay? So that brings us to today's lesson in the book, comparing rates. How can you use unit rates to compare? And then they give us a situation. Always look at your diagrams first, and you can see that we've got 2 times being run here. Ethan swam 11 laps in the pool in 8 minutes. Okay? So this must be Ethan right here. Okay? 11 laps in 8 minutes. Austin swam 7 laps in the same pool in 5 minutes. So up here, this must be Austin. Okay? Which boy swam at a faster rate? In order to answer that question, what we need to do is find the unit rates to compare who swam faster. So then the book goes through pretty much what we just went over in our review. We find a unit rate for each one of the swimmers. Okay, so we take Ethan's initial ratio of 11 to 8 minutes, 11 laps to 8 minutes, and we divide the first term by the second term. In other words, you would take your 11 and divide it by 8. When you do that, you get 1 3/8, which is equal to the decimal of 1 375 thousandths. So Ethan swam 1 375 thousandths of a lap in 1 minute. Okay, so in 1 minute, he swims a little over a lap. Okay? And then over here, you can see that we're going to find Austin's unit rate. His initial rate was 7 laps to 5 minutes. Okay? If we were to do the division, we would divide 7 by 5, and we would come up with 1 4/10 laps per minute. So Austin swam 1 4/10 laps per minute. Well, 1 4/10 laps is a farther distance per minute than 1 375,000ths of a lap. All right? So you can kind of see how the math works out. What you want to remember is to make unit rates first. Okay? So, a couple things to remember when comparing rates. First thing you want to remember, you need to create unit rates first before comparing. Okay? You need to create a unit rate first. And that's what they did up in the example. They took this rate and they made a unit rate. Okay? They took this rate and they made a unit rate out of it. The second thing you need to do when finding unit rates, you should set up the ratios in fraction form. Okay? Fraction form, just like we did up here. It makes it much easier to remember that you're dealing with a division situation. And the third thing is you may need to round to a common place value. In other words, in this situation, we were going to end up comparing 1 375,000ths to 1 4/10. Now remember, by annexing zeros, you create equivalencies. So in this case, you would then have something that looks very similar for comparison. Okay? And you could compare the place values easier. All right? Without getting confused. So anyways, what I'm going to do now is I'm going to stop this video and give you an opportunity to practice some of the problems in your book.